going to look at a specific idea here. And it's simply this. If we have to integrate something in the form of derivative times function to the power of n. So we're looking for things specifically in that. And if that's true, if we've got that situation, then I can simply add 1 to the power over the power. Basically, you're talking anarchy or the chain rule in reverse. So if we were differentiating, we would have bring down the power and the n plus 1s would cancel, lower the power, so the n plus 1 would become n, and then you go times the derivative of what's inside. So it's sort of saying, hey, I've got the answer, what was the question? Now, occasionally you'll see questions sort of set up in that they give you a really big hint on how to do it. And so they might say, hey, go and differentiate this particular function. Oh, okay. Well, derivative of 1 minus x to the power of a half. So bring down the power, lower the power, diff the inside. We end up with minus 3x squared over 2 root 1 minus x cubed. And then the second part of the question comes along, and amazingly, we have to integrate something that's very similar to the answer that we just got. That, of course, allows you to use the idea, oh, hang on, if I differentiate this, I get this. Therefore, logically, if I integrate this, I get this. Well, we want minus 3 times x squared, however. And we've just got x squared. But that's not a problem. I'll make it what I want. So, oh, sorry, it was minus 3 on 2, was it? So we make it minus 3 on 2. Can't change the question, though. So I balance it out by multiplying by minus 2/3. Well, we know the value of this integral is the square root of 1 minus x cubed. So that's one way they ask it, where they give you a really big hint on how to do it. When it's like this is where we need to recognize it. And I suppose you're looking at what's in the grouping symbol, and in the grouping symbol is 2 plus x squared. You say, well, gee, what I'd really like is the derivative times that. And the derivative of 2 plus x squared is 2x. I've only got 1x. That's okay, because I can multiply the x by 2 and then multiply the whole thing by half. The integral is now in the form derivative times the function to some power, that power being a half. So now I can simply add 1 to the power over the power. 2's cancel, and writing it in super mathematician form, of course, mere mortal might leave it as power of 3 on 2, but not us. 2 plus x squared, square root of 2 plus x squared. There is another way of doing this, which we'll look at in more detail next year. It's called a method called integration by substitution. Personally, I think it's easier to just do it this first way, where you just try and create, oh, well, derivative times function, then I've got it. But what people tend to do is they say, well, oh, this is a bit tricky. They say, I'm going to change the question. So I'm going to substitute in a different function. And what they do is they say, well, I'm going to let this thing under the square root sign just be u. Okay, so I can substitute in that. But see, the one thing with integrals is we don't mix our variables. So I can't have u's and x's in the same integral. I've got to substitute in for all these x's. So if that is u, then du dx would be 2x, and so du is 2x dx. So now I can substitute in and get rid of all of this, because there's u, and x dx, well, that's half of du. So I can change this to be a half u to the power of a half, and then go and integrate that. And that's a very simple one, it's just a single pronumeral. So add 1 to the power over the power. But of course we don't leave it like that, because the original question didn't have u. We've got to get the x back in there. So subbing back in for u, 2 plus x squared, and we come up with the same answer. Look, that technique's great for certain types of functions. Personally, I just think it's easier to look at it and go, I want to create derivative times function. to some power. Now, what's causing me the problem is the x cubed minus 2. That's in the grouping symbols. So what I'd really like is the derivative. Now, x cubed minus 2. What's the derivative of x cubed minus 2? I've got x squared, not 3x squared, but that's okay. Because I can multiply it by 3, but then divide it by 3 out the front. So I now have derivative times the function to some power. Power in this case is now negative 3. Okay, so there it is, derivative, function to some power. So I can get the function, add 1 to the power, over the power, and we're going to sub in from 1 to 0, and we get our answer. Now if we did this one by substitution, the way we would do it is we'd say, oh, gosh, all right, let's make this a bit easier. Inside the grouping symbols, I've got x cubed minus 2, so I'm going to let u equal that. U is going to be x cubed minus 2. So du, notice I left out the middle step where I go du dx is 3x squared. I've just gone straight to the du is 3x squared dx. So I can substitute in. However, once I change those pronumerals, these limits are no good, because those limits refer to x. My new pronumeral is u, so I have to substitute for those limits as well. And it's easy enough to do, because we have a formula here. U is x cubed minus 2. So when x is 0, u must be negative 2. And when x is 1, u must be negative 1. So I can substitute in, and there it is, 1/3 u to the negative 3, and we're now going from minus 2 to minus 1. Add 1 to the power over the power, substitute in, and voila, we get the correct answer. Once there's a u there, if you have limits of 0 and 1, you're wrong. Okay, that'll do it.